Hi guys, welcome to our next unit. It is about motion and forces. We're going to talk about the patterns of how things move, the rules of motion that every moving thing follows, and why that's so important to our daily life. So before we get into forces, the first part of this unit is going to be about motion. So when you hear the word motion, I know you think of movement, of something actually moving. That's what the word motion means. But we're going to call it a change in position. So you have an object and it's going to change from one position to another position. But one thing that's important to think about when you're talking about motion is your reference point. For example, if you are standing on the street, totally still, waiting to cross the street, and a car zooms past you at 45 miles per hour, it's going to look like that car is moving really fast, right? Because you are the reference point. You're still, the car is moving. However, if you are in another car also going 45 miles per hour and you're driving right next to that car that's also going 45 miles per hour, it feels like neither one of you is moving, right? And so then let's say that that car is speeds up just a little bit to maybe 47 miles per hour. If you're still driving 45 miles per hour, it's going to look like that car is moving forward past you, but very slowly because your reference point has changed. If your reference point is you standing still, then things are going to look like they're moving really fast. If your reference point is something that's also moving, then it might not look like it's moving fast. So when you're talking about motion, keep in mind it's all relative. If you're standing on the street and I'm driving in a car, something that's moving is going to look different to both of us. Motion is all relative. It just depends on your reference point. So also to talk about motion, we need to talk about distance and displacement. So distance is the length that the path actually, that the object actually travels. So if you'll follow my mouse here, if we look at this person started right here, right? Traveled 50 meters up here, then turned around and came 30 meters back. So this person actually moved 80 meters, right? 50 here plus 30 here. From the time that they started until the time that they stopped, they moved 80 meters. That's distance, just how far you went. Displacement, on the other hand, is the distance you end up from your starting point. So this person, if we look at the starting point right here and then measure to this person, the displacement is only 20 meters. Even though this person traveled 80 meters, they're only 20 meters away from where they started. So their displacement is 20 meters. How far away are you from your starting point? So I'm going to say that again. Distance, how far you actually went. Displacement, how far did you end up from where you started? You might actually end up right back where you started. If this person traveled 20 more meters, their displacement would be 0, even though their distance was pretty great. Same thing here. So let's pretend that you're jogging on a path, right? And the path is kind of curvy. So you jog all the way up here, follow my mouse. You jog over here, up here, up here. And so your distance is going to be pretty far, right? But if we draw a straight line from where you started to where you end, that's your displacement. That might not be the same as the distance that you traveled. So let's talk about speed. Everybody knows what the word speed means. It's really easy. It's just how fast something travels. That's it. And how fast something travels depends on two things: how far they went and how fast they got there. That's what speed is. It's how far an object traveled in a certain amount of time. We measure it in meters per second. In science, we don't usually say miles per hour because we like the metric system, so meters per second. And there are two types of speed. There's instantaneous speed and average speed. Instantaneous speed tells me how fast I'm going right now. When I look at my car speedometer, I might be going 45 miles per hour. That's an instantaneous speed, how fast I'm moving right that very second. If I look again a few minutes later, I might have slowed down to 30 miles per hour. So that's my next second instantaneous speed. I'm going 30 miles per hour right then. An average speed is a trip or a distance that something has traveled, and the average speed is just what it sounds like, the average speed, the total distance traveled by the total time. So if I drive from my house to Central Hardin High School, okay, I might go really slow through my neighborhood. I might speed up a little bit when I'm on the main road, and then I'm going to slow down again when I'm in the parking lot, right? So I have different instantaneous speeds. If you looked at my speedometer in my neighborhood versus on the highway, That's going to look different, right? But my average speed, I would take all of my instantaneous speeds, okay, and divide them, distance divided by time. How fast was my average speed as I was driving? So there's your speed calculation. And we're going to be doing some math this unit. So it's important that you remember these calculations. Speed is distance divided by time. We're going to come back to that slide in just a second. But look at this problem. The average speed of a car, if it traveled 750 meters in 25 seconds, okay? 750 meters is our distance. 25 seconds is our time. If we go back and look, speed down here at the bottom is distance divided by time. So we're going to do 750, that's our distance, divided by 25, that's our time. And we're going to get 30 meters per second. Okay, take a second if you need to pause it. Think about that for a second. Distance divided by time. Okay, 750 meters, that's our distance, divided by 25 seconds, that's our time. That gives us 30 meters per second. That was the average speed of the car. It could have sped up or slowed down along the way, but that was its average speed. So these are the three formulas you can use that deal with speed, distance, and time. The one that we just used is down here at the bottom. So if you know your distance and your time, you can find your speed. If you want to find distance, look at this top one right here. Distance is speed times time. If you want to find your time, then you need to look at your distance and divide it by your speed. So it's just three different ways to use the same formula to find whichever one you're looking for, basically. So again, pause the video if you need to, take a second to look at those. I am going to do an activity in class with this, though, where we will go over it in more detail, because I know math's not really something you can just get over a video. So we are going to sit down with these problems like this, but I just wanted to kind of show you that. We've done things like this before, so I don't think it'll be too hard when you see it. All right, the last thing we need to talk about is velocity. Velocity is really simple. It's just speed with a direction. That's it. It's just more specific speed. Speed tells you how fast something's going, but velocity just describes it in a little more detail and tells you how fast it's going, plus what direction it's moving in. So velocity has a size and a direction, and the size is the object's speed. So if I say I'm going 45 miles per hour, that's just a speed. I've just told you how fast I'm going. But if I get a little more specific, a little more fancy, and I say I'm going 45 miles per hour north, that is a velocity because I've just tacked on that direction there that makes it a little bit more specific. It doesn't have to be north, south, east, or west. It can just be like 45 miles per hour toward Central Hardin or toward Walmart, whatever. Those are all directions. It gives you an idea of where the object is traveling. It just makes the speed a little bit more specific. So that's all velocity is. Objects have different velocities if they're moving at different speeds, obviously, or in different directions. If we have the same speed, 45 miles per hour north, and you're going 45 miles per hour south, even though we have technically the same speed, 45 miles per hour, we have two different velocities because you're going south and I'm going north. So velocity is literally just speed plus a direction. Pretty simple. The math is the same. A boat is sailing at a constant velocity of 15 kilometers per hour south. So there's your velocity for 1.5 hours. So you can plug in velocity just like you can plug in speed. So we're trying to find the distance. It says right here, calculate the distance traveled. So if we go back and look at this, we're trying to find distance. So that's this first one right here. So we need to multiply speed times time. So if we go back and look at that again, our speed was 15 kilometers per hour south. Our time was 1.5 hours. So if we multiply that, 22.5 kilometers. So take a second and think about that. Again, don't worry too much about the math part right now. We're going to sit down and work on that in class. Hopefully, though, you've gotten the words speed and velocity. That's it for this video. Here's what I want you guys to do a little bit differently this time. Rather than give me a vocabulary word, what I want you to do is either fill out the fill in the blank notes if that was something you wanted to do and you've got those notes. Just go ahead and make sure you've got those filled out and you can show me those and that'll work. Obviously, you've watched the video. Or go ahead and in a private comment, or you can turn it in however you want to do it. Ask me a question about this video. Anything that you were confused about other than the math, because we're going to sit down with the math. But if the vocabulary confused you, if there was something I said that went too quickly or didn't make sense, let me know so that I can address it in class and make sure that we're all good before we do the activity. All right. Bye, guys. See you tomorrow.